Welcome to VSOM Tech Talk. Today we are going to discuss what is ML.NET and what are its components. Let's see the details in the next slide. Microsoft is introducing a new framework called ML.NET. So this ML.NET is open source, which is especially we are using that ML.NET for integrating the machine learning in .NET applications. So the developers who are familiar with .NET coding, they can use this ML.NET to integrate machine learning programming into .NET applications. That means if you are a C# developer, you don't need to learn any new programming language like Python or anything. You can directly use this ML.NET framework to integrate the machine learning programming in .NET applications. So in order to develop your own machine learning models, or you can use that custom machine learning programs into your .NET applications with the help of this ML.NET. So this framework offers various tools and features to help you easily build, train and deploy high quality custom machine learning models locally on your computer without requiring prior machine learning experience. Let's try to see each and every section in the ML.NET components. ML.NET components, majorly there are 7 major components are there, which you can see here. Under data components, data loaders is one part, data transformer is another part. So under training ML task component, we can see classical ML component and computer vision component. In the same way, when you are consuming or evaluating these models, we have consumption and evaluation. There are 2 more. Overall here 6, and finally we have various extension and tools are there which we are using for building the models and generating the code. So these are the various 7 components are majorly useful in ML.NET. Let's see in detail about each and every component. If you see the data component, this data component we are using in terms of loading the data in ML by using iDataView. So the data in ML.NET is represented in the form of iDataView. So this is nothing but a efficient way of loading the data in a tabular format. So iDataView provides a placeholder to load the data sets for further processing. There are a few more loaders are there, which is file loaders, database loaders, image loaders. These are the other loaders. If the data is available in the form of a text or images, we can use file loaders. If the data is need to be loaded from the database, we are going to use the database loader. If the data has images anything, then we are going to use image loaders. So the first section which we are talking about data loaders. Now let's see the data transformers. If you are going to use data which we are loading, that should be converted in acceptable format for machine learning algorithms. So in such a case, we are going to use data transformers. So all data need to be converted to numbers or numeric vectors. So ML provides a variety of data transformers like such as text featureizers and one hot encoders, which are going to use to convert your data in an acceptable format for machine learning algorithms. Now let's try to see another component, that is a training ML task. This component is especially useful when we want to train our models. So here the first component is classical ML, which is providing various algorithms or learning scenarios like classification, regression, anomaly detection, time series, and many learning scenarios and tasks are provided. So there are almost 40 training algorithms are there, which you can select and fine tune the specific algorithm to get the better accuracy of output in the machine learning. So to do that, we need to give training. So these are the various training algorithms are available in this component. Now the second section is like computer vision. This is another component in terms of training. So if you want to give training in terms of by using image, or we are going to use image classification. In such a case, we have ML.NET 1.4 preview packages are available in NuGet packages, which we are going to use that to identify, or we can give training by using image classifications or recognitions. Microsoft is working on adding support for object detection training as well. This is about training ML task. So once you have trained your custom ML model, so ML model is trained with the help of various training algorithms. So ML.NET provides several ways to make predictions. So those predictions we can do in the model consumption and evaluation component. So in terms of predicting, we are going to use a prediction engine or prediction engine pool. So with the prediction engine, you can make a single prediction. If you are going to use prediction engine pool for making predictions in scalable and multi-threaded applications. This is about prediction. So the stage 1, we are gathering the data. For loading the data, we are using a data component by using different data components. Now once we gather the data, we are going to train the model with the help of various algorithms. If you have any image related data is there, we are going to use computer vision component for training the model. Once the model training is over, we are going to consume that model. So that consumption we are going to use for prediction. Once you are going to do prediction with the help of prediction engine or prediction engine pool, we are going to evaluate whether our results are accurate or not with the help of various model evaluators or quality metrics. Now the final step is extension and tools. So this is about various tools are available in ML.NET framework, where like a model builder in VS is a UI tool where we are going to generate the code with the help of model builder. You don't need to write any code. CLI is nothing but command line interface. With the help of command line interface, also we are going to add the components to your application. AutoML is going to use in model builder. With the help of AutoML, we are going to generate the code for building the model. So TensorFlow and ONNX consumption we can discuss in the later videos.